All right, so this is the second part of the take-home task challenge for GoldenCity. This is my notes route JS component where I'm handling the API backend for routes. So what I'm doing first, what we usually do first is we import Express and we create a router object, which lets us define routes separately and later attach them to the main application. So we're of course using in-memory app storage, in-memory storage, meaning the notes are stored in a variable that only lasts while the app is running. So we're not using a traditional database here. Okay, so first of all, we have our post function. What we're doing here is we're expecting a request body with at least title and content. So here we're checking if either title or content exists. We're returning a 400 error that's saying title and content are required. So we're basically checking if this doesn't exist or this doesn't exist, then we are sending back the error because we need title and content for a note to work. So this is the part of the content that we are editing. Okay, so when we're done creating our note, it gets posted. So we are just pushing a note to the notes array that we've declared here. And we are sending back a successful 201 status for creating a new note. This function gets all the notes that we currently have in our notes array. So it just returns them all. It of course parses the JSON, and it doesn't require any parameters or a body. It's useful for listing just all existing nodes on a front end or testing the API. Okay, so here we're getting a specific node by ID. We're extracting the ID from the URL using required params ID and converting it to an integer. That's what we're doing here. So we're searching for a node with that ID in the nodes array. So yes, and if found, it gets returned, and if not, we are returning a 404 error with note not found. So here is my put function used for updating a note via ID. So of course we're finding the note via its ID. So if the node doesn't exist, we're returning a 404 not found response. If it exists, we are updating any fields provided in the request, and the possible fields to be updated, as I mentioned earlier, are title, content, and status. So we're also updating the updated at timestamp to the current time, unless a custom one is given every time we edit a note. So of course, created at stays the same because it was already created back at that time, but this one updates with the edit. And finally, we are returning the updated note. Okay, so one more API. It's the delete router delete by ID. So we are finding the index of the node with the given ID. Then if the node doesn't exist, of course, after this, we're just returning a 404 not found. If it does exist, we are removing it from the nodes array using the splice method. And we are responding with 204 no content to indicate a successful deletion with, of course, no body. So this data is stored temporarily in memory, and it resets every time when the server restarts. That was the functionality requested in the task. So each node has fields like ID, title, content, status, created at, and updated at. The API supports CRUD operations using RESTful routes. And there's, of course, some soft error handling included for missing data and invalid IDs. That being said, let's move on to the application to show this functionality on live on the page. So here I've just added a notes link. It takes us. I've added the animation to be consistent with the others. It takes us to the notes page. So what I'm going to do is, of course, create a new note. We're going to call it note to self, and the description. This is a test self-explanatory note. Okay, so the status of the note is active. We're going to add it, and of course it gets. Now I'm just going to open the network tab in my developer tools. So of course we're adding a new note to self, and we can just add 1, 2, 3 to this description. We're going to set this one as completed. Okay, so here's the response. It's saying post to a one created, as it should. We're just going to edit this note now. We're going to say note to yourself, note to you. Just going to say note to you. That's correct. And we're going to complete that. So here I'm going to click update. Of course, it sends us the ID of the note that's being updated, which is 1. If it would send the index of the array, it would probably send 0. So okay, here we have a successful request. I'm just going to add another one, delete, note to delete. Of course, if there's no description, then we're asking for one. I also added that. So we're going to create that one here. Another one was created. And I added a little modal to ask, are you sure that you want to delete the note? And of course, we're getting a ID of 3 with a 204 no content status code deleted. Well, that covers this part of the task assignment. Everyone, greetings. My name is Maxim. I'm a full stack developer, and I'm here to present the take-home challenge test task. Let's get right into it. First, I want to explain my Connect Wallet JSX component logic, specifically for example for Coinbase. So here I'm defining a constant connect Coinbase. It's obviously a asynchronous function. So the first thing I did was check if window Ethereum and window Ethereum is Coinbase wallet. So this basically checks if whether the user already has a Coinbase wallet injected into the browser, like a browser extension. So, and if the wallet is Coinbase specifically, then we are moving forward to request users permission to access their wallet address. All right. So here we are. So here we're initializing the Coinbase Wallet SDK. Then we are passing in our variables for app name, logo URL, and I set up a dark mode one. It's just as false, less relevant. But anyway, here we're creating a Web3 provider using the SDK network ID 1. That's Ethereum mainnet. So here we are prompting the user to connect their wallet through SDK. We're creating an Ether.js provider from the SDK provider. So here we're just getting a signer from the new provider, and we're fetching the connected wallet address here. So const address is await signer get address. So here we're gonna save the wallet address in our application state. And here we are going to store the SDK, the SDK provider in app state for opening the modal. And then this button also does the same. I made it persistent across the entire application, and it also exists here. So for example, we can do this and then we just click on Coinbase Wallet, handle the request. So here we have connecting. So here we can connect our Coinbase Wallet app directly. So first we need to open Coinbase Wallet app in order to scan the QR code, which then connects our wallet to Coinbase. Or we can try the Coinbase Wallet browser extension to be installed, clicking on this link. So yeah, that's basically it for the first assignment. All right, for the last part of the assignment for the Golden City Take Home Challenge, I want to share some best practices and some tools for image optimization to improve the site's performance on first load. So basically, the only change in code I made to optimize this is just adding a loading property to each image within the application and setting that to lazy. Basically, what this does is it doesn't load the images automatically, it loads everything, and if something takes a longer time to load, it doesn't prioritize that to load before everything else, but rather the other way around. So for compressed images, uh, we should ensure that all images are optimized using tools like Tiny PNG or Image Optimizer, Image Optim actually. We should use modern image formats like WebP or AVIF for smaller file sizes. And we should, of course, implement lazy loading for images using the loading lazy attribute in image tags like I did, or maybe use a library like React Lazy Load. There's a lot of middleware that can help achieve improving the site's performance. So regarding minimizing JS and CSS bundles, we can use a method called tree shaking, ensuring unused code is removed during the build process. Tools like Webpack that you already have embedded into the application can help with this. So code splitting, like dynamic imports to split large bundles into smaller bits, and React supports this with React Lazy Load, React Lazy, or React Lazy Load. I can't remember right now, and Suspense. So we should ensure our assets, our files are minified, and this can be done using tools like Cursor, or Cursor is for JS, and CSS Nano is for CSS. And basically, so yeah, I did open the site on Safari and Firefox, and the reason for some of the differences are just some CSS properties like grid, flexbox, that behave differently across browsers. And using uh, some tools, we can check this compatibility, of course, or we can just do manual testing. Some JavaScript features I know that, like for example, optional chaining and knowledge coalescing, they not maybe they may be not fully supported in older versions of Safari or Firefox. So we should use a Babel transpiler for better compatibility. And vendor prefixes. Some CSS properties require a vendor prefix, like WebKit for Safari. And tools, we can use some tools like Prefixer or Auto Prefixer. I can't really remember the name right now, but that can automate this process. And of course, browsers have different default styles for elements. We can use a library called normalize CSS to ensure consistent styling across each browser. So yeah, the way I tested this was using developer tools on Safari and Firefox. I did this on my laptop, and I was checking the console errors or warnings related to unsupported features. And this is how I found this information out. So yeah. So basically, in summary, we should optimize images and analyze bundle size to improve performance. And we should debug and fix browser specific issues by identifying incompatible CSS and JS features and applying necessary fallbacks to this. So it was a pleasure doing this task. It was a lot of fun. And for any questions that need to be fulfilled or any thorough or extensive explanation, I am at your service. And yeah, goodbye for now.